Hello everyone. The title of this video is Plotting a Complex Number on the Complex Plane. Now each example I'm going to be doing is taken directly from either the examples or the try it problems or the exercises at the end of the section from a section 2.4 of a free online textbook at openstax.org. It's the Algebra and Trigonometry textbook. Again, I'm in section 2.4 on complex numbers, and I'm working on the objective heading Plotting a Complex Number on the Complex Plane. Alright, so I would ask that you have read through this and also, practice exercises that I bring up by pausing the video first and then trying it yourself before watching me doing and comparing. Great. So I have all the examples written out on paper here. So again, we're just simply asked to plot the number on the complex plane. So first I want to talk about, off to the side here, the complex numbers, the complex number system. All right. So each complex number, well, basically every number you're going to see and work with in an algebra course is considered complex. The standard form for a complex number, the form that any number can be written in, is a plus b times I. A plus bi, where a and b, right, the a and the b, these are real numbers, and hopefully you recall this I, right? I was that imaginary unit. It's the principal square root of -1, right? It is a number that when you square it, you'd get -1. Right, so every number is complex, and every complex number can be expressed in this way as a real number a plus an imaginary number bi. And the number a, right, that doesn't have the I attached, right, it's strictly real on its own. This would be called the real part of the complex number. And the number b that's attached to the I, right, the coefficient of the imaginary term, is called the imaginary part, right? So just the number b itself, right, the real number in front of the I, this is called the imaginary part of the complex number. All right, and then a couple more things. If the imaginary part, if b is 0, then the complex number can be considered just a real number. So if b equals 0, the number is strictly a real number. Right, for example, 3 plus 0i would just be 3. Right, 5 plus 0i would just be 5. Right, because it's just like adding 0 to something, right? It doesn't actually change the value. So a plus 0i would just be the real number a. And if the real part is 0, right, if a is 0, so 0 plus 1i, 0 minus I, 0 plus 2i, 0 minus 4i, whatever. If the real part is 0, well then the number is imaginary. Only 0, if only the imaginary part is 0, the number is real. If only the imaginary part is 0, the number is imaginary. And I guess if both are 0, well then we'll just consider it the number 0, the real number 0. Okay. Alright, so we're seeing some examples of complex numbers over here. Alright, we have 3 minus 4i. So a is 3, right? The real part is 3. And the b, the imaginary part, is negative 4. Don't forget negatives, right? You can always write this as 3 plus negative 4i. So the real part 3, the imaginary part is negative 4. And here, negative 4 minus I, the real part, the a, is negative 4. And the imaginary part, right, the b, is negative 1. Because again, you can think of this as negative 4 plus negative 1 times I. Now, when they talk about plotting a number on the complex plane, let me pull up a separate sheet here. Talk about what's the complex plane. Now this is something you're probably not going to use all too much, especially in a beginning algebra course, but I wanted to at least introduce it here. The complex plane, right, it's a plane, so it's a two-dimensional figure, like a sheet of paper that goes off in all directions. It's just like the Cartesian coordinate system, just like the xy plane. You have a horizontal axis and you have a perpendicular, vertical axis. Alright, but instead of calling these the x-axis and y-axis like you're used to, the horizontal axis is the real axis. So the horizontal axis represents, the real parts of a complex number, right? So the possible values of a, right, the real part. And the vertical axis is the imaginary axis. And this number, and they're number lines, right? You got 0 in the middle where they meet, positive numbers to the right, negative numbers to the left, and the imaginary axis, 0 in the middle, positive numbers going up, negative numbers going down. And again, this vertical imaginary axis just represents possible values of b, right? The imaginary part of a complex number. So this is, possible values of a, right, the real part, in a plus bi, and the imaginary axis has the possible values of b, right, the imaginary part of a plus bi. So, in example 1, we're asked to plot the number, 3 minus 4i in the complex plane. Right, so the real part, right, remember the real part, right, that value of a in a plus bi here is 3. So I go to positive 3 on the real axis, the horizontal axis. So there's positive 3. And then the imaginary part of this number, 3 minus 4i, the value of b is negative 4. So on the vertical imaginary axis, I go to negative 4, so I'm going to get 0 in the middle, and negative 1, 2, 3, 4 down. Right? And then the point on this plane that represents this number is the point that's in line with 3 on the real part and negative on the real axis, and negative 4 on the imaginary axis. So this point right here, right, that big dot I just made. And to label it, I'm putting 3 minus 4i. I'm going to label it with the number that it represents. All right, so again, it's just like plotting an ordered pair, just like plotting a point in the xy coordinate system. Right, only, once again, the horizontal axis is the real numbers, the real part of the complex number, and the vertical axis is the imaginary part of the complex number. Great. All right, so for example 2, just going to keep this same plane up here. Again, we're given the number, negative 4 minus I, or negative 4 plus negative I. So again, the real part, right, the value of a in the standard form, a plus bi for a complex number, would be negative 4 here. So I'm going to go on the real axis and find negative 4. So again, you got 0 in the middle, and then 4 to the left. 4 units to the left would be negative 4 on the real number axis, the real part axis. And the imaginary part, again, the value of b in the standard form, a plus bi, would be negative 1. So I go to negative 1 on the vertical axis, the imaginary part axis. And so there's, negative 4 on the real, negative 1 on the imaginary. This point right here, this location on the complex plane, that point represents the complex number negative 4 minus I. And I'll label it with the number that it represents. Okay, and it's just like plotting the ordered pair negative 4, negative 1, right? Negative 4 comma negative 1 with x value, y value on the xy plane. The only difference here is now these aren't ordered pairs. These aren't representing pairs of real numbers. These points are now representing a single complex number. Right? That point there is one number, 3 minus 4i. That point there is one number, negative 4 minus I. All right, and I'll just do this with 2 more. Got 2 more. So again, I'll just do it on this same complex plane here. So example 3, we're asked to plot the negative 2 plus 3i, and the real part is negative 2. The imaginary part is the positive 3 attached to the I. So if I want to plot this number on the plane, go to negative 2 on the real part axis, and then positive 3, which would be 3 above the center, the origin. Positive 3 on the imaginary part axis. And here we go, right? 3 on the imaginary, negative 2 on the real. That's this location right here, this big dot right here. And again, that doesn't represent a pair of real numbers this time, right? Now this point represents a single number, one complex number, namely negative 2 plus 3i. Great. Again, pretty simple stuff in my opinion. And then this last example I have here, and I'll do some other ones, I guess, might as well. But we have, the complex number, negative 3 minus 4i. So again, easy, just identify the real part, the term, without I attached to it. Right, so the real part of this number is negative 3. And the imaginary part is the number -4, right? Remember, this is plus -4i. So -3 on the real part axis, -4 on the imaginary part axis. And here we go, -3 on the real, -4 on the imaginary. That's this location right here. You know, in the third quadrant. Remember the quadrants 1, 2, 3, and 4 going counterclockwise from the upper right. And once again, this does not represent, in this context, this does not represent a pair of real numbers. This represents a single complex number, right? Namely the number -3 minus 4i. Right? All right, and then you know, I'll just put up some other points here and show you what they would identify. Right? Any point that's on the real axis just represents a real number. Right? So like this point I plotted here, this is 2 plus 0i, or just 2. Right? Because there's no real point in writing 0i. And then any point that's on the imaginary axis, so say this point here, is strictly imaginary. This point would represent, you know, 0 minus 2i, right? It has a real part of 0 and an imaginary part of -2, or just -2i, right? Just an imaginary number. All right, so please understand that, you know, if you're on the real axis, your imaginary part is 0, and if you're on the imaginary axis, the real part is 0. All right. Yeah, but pretty simple stuff, in my opinion. And like I said earlier, you know, you're probably not going to be plotting these things on the complex plane all too much early on when you're introduced to complex numbers. The complex plane actually comes more in handy when you're finding the absolute value of a complex number. It could also come in handy when you're adding or subtracting complex numbers, when you're multiplying complex numbers, finding roots of complex numbers. Like, the plane is very nice for visual representations. It's just I don't feel like I'm going to be, they don't use it all too much in this text that I'm looking at, this algebra and trigonometry text from OpenStax. You know, it's introduced here, but not really brought up all that much in later sections. Okay. Great. So hopefully you understood the complex numbers introduction. You know, every number, real number, imaginary number, and any combination of them is a complex number. And that's the standard form. Get that down. Real part, you know, real number plus imaginary number, a plus bi. And I'm hoping that the complex plane made sense as well. Right? And that watching me go over these several examples here will help you out in some way when you're asked to plot a number on the complex plane on your own. Okay, and thank you very much for watching.